Hello and welcome to Science at NTC. We are a site dedicated to helping you improve your grades in O-level science, that is physics and chemistry. I encourage you to follow us on our Facebook page NTC and subscribe to our YouTube channel for more video lessons. Our YouTube channel is NTC. Enjoy the following unit on atomic physics, and I am your instructor, Alex Nkumbi. Just to make an introduction to atomic physics encompasses such areas as the structure of an atom itself, which is very important in making you understand the topics to follow. Then we'll talk about the stability of the nuclear atom. Then we talk about radioactivity itself and its characteristics, and of course its applications in everyday life. And then we also talk about nuclear reactions and radioactive decay. So for now, let us take a journey and look at the structure of an atom so that we can lay a foundation that we are going to depend on for us to learn the other following subtopics. Okay. So what will be covered under the structure of an atom is as follows. We shall look at the general structure of an atom, and then we shall look at how to denote the nuclide of an element, and we also look at the terms associated with the nuclide. Excuse me. Then we shall also look at how to determine the number of neutrons of a nuclide, if you are provided the nucleon number and the proton number. Then we shall look at sample questions from past papers concerning the structure of an atom. Thereafter, in another section, that's when we shall introduce radioactivity. But for this particular lesson, we will just look at the structure of an atom and all the terms associated with it and the calculations involved. So the first thing is we want to look at how an atom is structured. To begin with, we understand that matter is built from atoms, or in short, atoms are the basic building blocks of matter. So whichever form of matter we may be dealing with, it may be in gaseous form, it may be in solid form, or in liquid form, matter is made up of atoms. So an atom is the smallest unit of matter. Then we know that all matter contain atoms, because we are saying that matter is made up of atoms. So we are saying all matter therefore contains atoms. And an atom itself consists of a nucleus, that is the center of an atom, and this center contains neutrons, colored green in this particular case, the particles we see there, and protons, that is the one with a positive sign. And then the nucleus is surrounded by a cloud of electrons, or we simply say shells. An atom shown in this particular case is that of helium, with only one shell, and it has only 2 electrons in its one and only shell. Otherwise, this is not the case with all the atoms. An atom of hydrogen also has one shell with only 1 electron. Then we have lithium, which has 2 shells. So it depends on the number of electrons. An atom of sodium, for example, has 3 shells. It has the first shell with 2 electrons, the second shell with 8 electrons, and the last shell with only 1 electron. So basically, this is the structure of an atom. So an atom comprises of the center, or the core, which is the nucleus, and the nucleus contains the protons and neutrons. Then outside the nucleus we have the shells, and the shells contain electrons. This is just a model of an atom. It might not be the exact, but it will help us understand the basic structure of an atom, of an element. Then we want to look at the protons and neutrons in details. like I said earlier, protons and neutrons are found in the center of an atom, and we call that center the nucleus. So a proton may be in simple terms be described as simply a positive particle found in the nucleus of an atom. But we can be more specific and say a proton is a hydrogen atom minus an electron. This description of a proton relies on the fact that when you look at a hydrogen atom, it has only one proton in its nucleus, there is no neutron, and it has only one electron surrounding it. So if the electron in the shell is removed, then what remains of the hydrogen atom is only a proton. So it is from that understanding that we know that when a hydrogen atom is scrapped of its electron, it remains as a proton. So we can use this basis to describe what a proton is. However, in simple terms, you can simply say a proton is a positive particle found in the nucleus of an atom. Okay, we can say that a proton has a positive charge, like I have already said. If you remove the electron from a hydrogen atom, what remains of the hydrogen atom is just a positive charge, a positive particle in the center. So therefore a proton has a positive charge, and the positive charge of a proton in terms of size, it is equal to the charge of an electron. The only difference is that an electron is negatively charged while a proton is positively charged. Then when we compare to mass, as we shall see in the coming slide, you discover that there is a very big difference between the mass of a proton and the mass of an electron. Actually, a proton is almost 2,000 times greater in terms of mass than an electron. Alright, so we have talked about one particle that is found in the nucleus of an atom, that is a proton. So we have said it's positively charged, and its charge in terms of size is equal to that of an electron, only that they are charged oppositely, proton being positive and electron being negative. And we have said that a proton in terms of mass is 2,000 times, almost 2,000 times greater than the mass of an electron. So let us now look at a neutron. So a neutron, as the name suggests, is neutral. It is uncharged, and it is found in the nucleus of an atom. So earlier we said, when we looked at the structure of an atom, that there are two types of particles found in the nucleus of an atom. That is the neutrons. So these neutrons have no charge, and then the protons with positive charge. So from here we can see that the charge of the nucleus is contributed only by the protons, since the charge of neutrons is 0. And in terms of mass, the mass of a neutron is the same, equal to the mass of a proton. So the difference between a proton and the neutron is that a neutron is not charged, it's neutral. A proton is positive. In terms of mass, their masses are equal. One neutron has the same mass as the mass of a proton. So protons and neutrons, because of being found in the nucleus, as you can see here, because they are found in the nucleus, we call them nucleons. So nucleons are particles found in the nucleus of an atom. So by nucleons, we refer to those particles, the protons and neutrons, because they are the ones that are found in the nucleus of an atom. So, and together they account for the mass of an atom. Like earlier said, the mass of a proton, the mass of a neutron that is found, of an electron that is found outside the nucleus, is negligible, because as you can see, the mass of an electron the mass of a proton or the mass of a neutron is 2,000 times greater than the mass of an electron. So in terms of contributing to the mass of an atom, the mass of an electron is negligible. So that's why there is this statement here to say together electrons and protons and neutrons or nucleons account for the mass of the atom, of the nucleus, and most of that of the atom, because electrons contribute almost nothing in terms of mass. So protons account for the positive charge of the nucleus, because we know the neutrons have no charge. The facts talked about here can be summarized in this table. So as you can see in this table, it is talking about the characteristics of the particles in an atom. So you can see a proton in terms of its relative mass it is 1. Now you have to understand that this mass we are talking about here is not in grams, in kilograms, in milligrams, no, but it is in assigned units called atomic mass units. Okay, so the relative mass of a proton is 1. Its charge is positive. The E here is to compare to the charge of an electron, so that we can see that the charge of an electron and the charge of a proton are equal in size, but they are only different in their charge. So a proton is found in the nucleus, that is the location. It is positively charged, it has a mass of 1. An electron has a mass of 1 over 1,840. It is this number that made me to say at this point here that the mass of a proton is almost 2,000 greater than that of an electron. As you can see, if you rounded off this number, it is almost 2,000. So when we compare the mass of a proton to that of an electron, we get 1 over 1,840. Now this is a very small fraction, such that even if you had a number of these, 20 of them, 30, 40, their mass will still contribute almost nothing to the total mass of an atom when you compare to the mass of a proton and the mass of a neutron. Okay, so an electron has a charge of negative, and its location is around the nucleus or outside the nucleus in shells or electron clouds. Then we have the neutron with a mass of 1. So you can see the mass of a proton and the mass of a neutron are equal. Its charge is 0, that's why it is neutral, and its location is in the nucleus of an atom. Okay, so we move a step further to look at atomic number. Remember, there was a point where we said we shall look at terms associated with the nuclide of an atom. We have not yet come to the nuclide, but first of all, let us look at these terms. The atomic number of an atom of an element, or simply the atomic number of an element, as we see it even on the periodic table, the atomic number, which is also called the proton number, is the number of protons in the nucleus of an atom. It is denoted by the symbol letter Z or Z. Now you have to understand here that it is not possible for two elements to have the same atomic number. If a situation arose where two elements had the same atomic number but they have different mass numbers, then the conclusion is that they are actually the same element, just existing in different isotopes, as we shall see. So atomic number is the number of protons in the nucleus of an atom. It is also called proton number, and it can be used to identify an element, since each atomic number is particular for a certain element. It's not possible, like I have said earlier, for two elements to share atomic number, the same atomic number. Then we have another term here, the number of neutrons. Now the number of neutrons is just the number of neutrons in the nucleus of an atom, and it is denoted by the capital letter N. the sum of protons and neutrons in the nucleus. So if we are to find the sum of protons and neutrons in the nucleus of an atom, that sum is what we call nucleon number, or simply the mass number of an element. So we know that each proton has a mass of 1, each neutron has a mass of 1. So if we have 10 protons, it means that the mass of those protons is 10. If we have 8 neutrons, it means the mass of those neutrons is 8. Now if we bring them together, because earlier we made this, there was a statement to say that these nucleons, they account for the mass of the nucleus and most of that of an atom. So therefore, counting the number of neutrons and electrons and then putting them together gives us the nucleon number, or simply the mass number. So that information is summarized in this simple equation, where letter A stands for nucleon number or mass number, and it is equal to Z, which is atomic number, plus the neutron number. Okay, so A is mass number. It's mass number, or it is also called the nucleon number. So nucleon number or mass number is equal to the sum of protons and neutrons in the nucleus of an atom. All right. Now we have come to the nuclide. So what is a nuclide then? I earlier said that we'll look at a nuclide and the terms associated with it. We have already looked at the terms associated with a nuclide. We have looked at mass number. We have that is also called nucleon number. We have looked at proton number, which is also called simply number of protons in the nucleus of an atom. We have looked also at the neutron number, or simply the number of neutrons. Okay, now a nuclide is a form in which the nucleus of an element is expressed. Okay, let us take for instance an element X, X standing for n element. It could be carbon, sodium, oxygen, n element we may think of. So when an element is shown on the periodic table, it has a number A on top and it has a number Z below. For example, if we use the particular example of carbon 12, so carbon on the periodic table, you see a 12 on top and 6 below. So this expression, this way of expressing an atom of an element in this form is what we call a nuclide. So a nuclide is a form in which the nucleus of an element is expressed, and when it is expressed in this form, it means that it is able to give us information in terms of the mass number or nucleon number and the atomic number of that particular element. Of course, even the symbol of that element, like in this particular case, letter C capital stands for the chemical symbol of carbon. Now, we have looked at an equation that we can use to relate mass number or nucleon number to proton number and neutron number. Now, when we look at a nuclide, like in this particular case, an actual example of a nuclide of carbon 12, we can see from here the information we are getting is that in an atom of carbon 12, the nucleus contains 12 particles altogether. That's the nucleon number. Now these particles, the 12 particles, 6 of them here are protons, because this is proton number. Okay? So this means that there are 6 protons and 12 nucleons, that is protons together with neutrons, in the nuclide of carbon 12. So if we were number, so in carbon 12 there are 6 neutrons, that is A, that is 12, minus Z, which is this 6. So 12 minus 6, we arrive at 6. So that is the number of neutrons in carbon 12. It is very important to take note of how to calculate neutron number, how to express the nuclide of an element, as we shall see when we come to look at some examples from past papers. Okay, then I earlier mentioned something concerning isotopes when I said it's not possible for two elements to share the same atomic number or proton number. If that happens, then it means they are not actually different elements. It's the same element existing in isotopes. So we would like to know now, what are isotopes? Okay, isotopes can be described simply as atoms of the same element with the same atomic number or proton number, but different mass number or different nucleon number. Okay, now the difference in nucleon number or in mass number arises from the fact that the isotopes of the same element have different number of neutrons in the nucleus. They will have the same number of protons, that's why they have the same atomic number, but they have different number of neutrons, hence their masses are different. So that's the point emphasized here. Isotopes of an element are atoms that have the same number of protons but different number of neutrons, and this difference in the number of neutrons is what makes the mass numbers to be different. So that is to say their proton numbers are the same but not their nucleon numbers, meaning not their mass numbers. So we can look at an example now. Carbon exists in two isotopes. There is carbon 12 given by this symbol, and then there is by this nuclide here, and also carbon 14, and the nuclide is shown here. So as you can see, when we subtract so that we can get the number of neutrons, from 12 we subtract 6, we are going to get 6 neutrons in carbon 12. But when it comes to carbon 14, when you subtract from 14, you subtract 6, you are going to get 8. So we can see that carbon 12 has 6 neutrons, while carbon 14 has 8 neutrons. This is the reason why they have different masses. It's very important, again I have to emphasize here, for you to understand the meaning of the term isotope, because when we begin to look at radioactivity, these terms will be coming back. We'll be looking at radioisotopes. So for us to be able to understand what radioisotopes are, it will be important if we have already understood. It will be easy if we have already understood the meaning of isotopes. Okay. Now it's time for us to look at how questions from the structure of an atom can appear in an exam. I want to tell you that the questions I have assembled, I have collected, are from past papers, and that they were appearing under atomic physics. So you may find some questions on radioactivity, on calculations of half-life, things like radioactive decay. We are not interested in that at the moment. We just want to look at questions concerning the structure of an atom, questions concerning the things we have learned. So let us look at this question. Okay. So this question was question 8 of this particular paper. So it says uranium 238. As you can see, this uranium nuclide has 238 as its mass number, and 92 as its atomic number or proton number, decays to form the nucleus of thorium. Like I said, we are not interested in the decay at this level. We'll look at it in the next session. By emission of alpha particle. Thorium as the symbol, 234 as its mass, and 90 as its atomic number, and its symbol capital T and H, like you can see. Now, the question I'm interested in here first is this one. What is the meaning of nucleon number? And you get yourself 1 mark. Okay, so it will be very important for you to realize that nucleon number is something that we covered when we looked at this. So we said the sum of protons and neutrons in the nucleus of an atom is called the nucleon number. So you simply stating that nucleon number is the sum of protons and neutrons in the nucleus of an atom, you score yourself this 1 mark in an exam. As simple as that. Okay, so we move to the next equation. When a large star explodes, nuclei of heavy elements are formed. One such nucleus is uranium-235. So when we say uranium-235, it means its mass is 235. the emphasis here of mentioning the mass is because this is one isotope of uranium. There can be other isotopes. Like in this case, you can see here that this uranium shown on top is 238. This uranium here is 235. So they are isotopes of the same element. Okay, now let's look at these questions. State the name and the number of each type of particles found in one nucleus of uranium 235. Okay, so here, name of particle. Remember, we are talking about particles found in the nucleus. So we are talking about nucleons. And we said that nucleons are those particles found in the nucleus. And we said neutrons and protons are in the nucleus and are called nucleons. So we are talking about particles found in the nucleus. So name of particle, we can start with neutron if we want, or we can start with proton. So name of particle, proton. Number found in the nucleus, proton number is simply this number below, so it's 92 there. You score yourself 1 mark if you get it correct here and here. That's a mark out of these 2 marks. Then name of particle, if we started with proton, then here it will be neutron. Number of particles in the nucleus, that is where now this equation becomes applicable. So n is equal to a minus z. So you simply say a minus z, that's 235 minus 92, and you find the number of neutrons, and you get yourself these 2 marks. Then let's look at the last question. State one feature that is the same for the nuclei of all isotopes of uranium. Okay, one feature that is the same for all isotopes. So remember, from the definition of isotopes, we said they have the same number of protons. Number of protons is the same. We can see this even from the nuclides given for these 2 isotopes. This is 235, its atomic number or number of protons is 92. This is 238, its proton number is still 92. So this 1 mark, you can score it by simply saying the number of protons. So we are looking at a feature that is the same for all isotopes of uranium. So the feature is they all have 92 protons. So they all have 92 protons, or simply number of protons. You score that one. Okay, let's move and look at another one. Okay. So here we have another question 8 from another paper. It says hydrogen nuclei fuse together in the sun. Again, we are not interested in fusion at this level. The nucleus of one isotope of hydrogen contains 1 proton and has a nuclide notation of this H capital 1 1. Other isotopes of hydrogen have the nuclide notation 2 with 1 as its atomic number, 3 with 1 as atomic number. Okay, now the question is state the number of protons. State the number of protons and the number of neutrons in the nucleus of each of the 2 other isotopes of hydrogen. That is this one and this one. We don't want to look at this one. They have given us this and this. So the question is state the number of protons and the neutrons. So for this one, the number of protons is simply the one below there. That's the number of protons, and the number of neutrons, we calculate number of neutrons by subtracting z from a. N is equal to a minus z, or simply from the number on top you subtract the number below, so you get your number of neutrons. So it is 2 minus 1, which is 1. So for this one, number of protons is 1, number of neutrons 1. For this one, number of protons is 1, number of neutrons, it will be 3 minus 1, which is 2. Just doing that, you would have scored yourself 2 marks. We are not going to look at this question and this question. We will come to these when we cover nuclear reactions such as fission and fusion. For now, our interest was just to look at questions relating to the things we have covered. Okay. Next, we look at another question, came from another past paper. Some atoms that undergo radioactive decay have a half-life of 6 hours. The count rate near... Okay, all this information is not necessary for now because that's not what we are. We'll come back to this. What we are interested in this particular question is this question carrying 3 marks. It says, describe the structure of an atom. And it gives some help or hint here to say it may help to draw a diagram. So you want to, this question is asking us to describe the structure of an atom. Actually, we started from there. So it's just a matter of realizing that an atom has the nucleus, which is the center, contains protons and neutrons, and it has shells containing electrons. So you like the hint is saying on that particular question, you do well to draw and then give your explanation to say the structure of an atom is in such a way that it comprises of the nucleus, which is the center, and the nucleus contains protons, which are positively charged particles, and neutrons, which are zero or uncharged particles. And then surrounding the nucleus, there are electron shells, and they contain electrons. Electrons are negatively charged. That is what is going to help you to score the 3 marks. So these questions were assembled to help us to actually relate what we have learned to what comes in actual. You can consider doing this exercise. Chlorine has 2 isotopes, one of nucleon number 35 and one of nucleon number 37. The proton number of chlorine is 17. That's the proton number. The table refers to neutral atoms of chlorine, meaning the number of, when we say neutral, it means that the number of electrons is equal to the number of protons because it has not yet undergone a reaction or nothing, no electron has been knocked off. So it's not an ion, but an atom. So copy and complete the table. This is the task that I want you to do. So proton number, the nucleon number is 35. The nucleon number for the other one is 37. We are told that the proton number is 17. So for you to complete this table, you should have an idea of isotopes, and you should also have an idea of how to calculate the nucleon number, and also how to identify which one is the number of protons. Okay, so for now we can say we have come to the end of our lesson on the structure of an atom. Make sure that you make a date with us in our next lesson on radioactivity. As I'll be introducing radioactivity, we have laid a foundation, and that foundation of atomic structure is the one that we are going to depend on for us to be able to understand our next unit, that is radioactivity. Thank you very much for watching this video. Make sure that you subscribe to our YouTube, that is the channel NTC, and also follow us on our Facebook page NTC. Soon we are opening a blog where we can interact so that you can share your ideas. You can actually present questions so that as a community of people involved or people who are dealing with O-level physics, we can help each other. Thank you so much. Hope to see you in the next lesson.